Today our objective is that you will demonstrate the effects of changing dimensions on perimeter area and volume, and this part 2 of the video is going to focus on algebraic manipulation. This is one of my favorite things to do in geometry. I'm very excited that you get to learn about this today. So, here's what we're doing. We've got a triangle here, and the question is, what happens to the perimeter when the dimensions multiply by 5? Now, you've already done examples. You already know that the answer is the perimeter is going to multiply by 5. That's okay to know that beforehand. What we're really going to do is algebraically prove this, not for just one example with some numbers, but for all examples, no matter what the numbers are. So, what I would like you to do, since we're doing this algebraically generally, is this. Can you label that first triangle ABC? This is just to help you visualize this. You don't actually need a picture to do what we're about to do. And it asks for the perimeter. Well, let's do what we did in the first section. Can you write P0, your original perimeter, is equal to, well, perimeter is all the sides added together, so that would be A plus B plus C. Now, let's consider what happens when the dimensions multiply by 5. So, if these dimensions multiply by 5, in this new triangle, there wouldn't be an A there would be a 5A because it multiplied by 5. And right here, there would be a 5B. And right here, there would be a 5C. So I want to consider the perimeter of the new triangle. You notice I just left it as a P. And in this case, it would be 5A plus 5B plus 5C. Now what we're going to do is make the right side of the equation, we're going to manipulate it until it looks like this, until I see just A plus B plus C in that equation. It won't be the whole thing, but it'll be part of it. And in this example, what we're going to do is factor out a 5. Factoring means that we're kind of undistributing the 5 from each of these three terms. You probably remember what this looks like from Algebra 1. You would put a 5 in front of the parentheses, and you would be left with A plus B plus C. Again, this is undistributing. If you distributed in the 5, you would get 5A plus 5B plus 5C. So, what I want you to notice right now is this. A plus B plus C is right here. A plus B plus C equals P0, the original perimeter. So I'm going to slightly rewrite this line right here, and so it says perimeter equals 5 times P sub 0, because A plus B plus C is the same thing as the original perimeter. And we're done. We've proven it. Do you see what this says? It says the perimeter is equal to 5 times the original perimeter. And that's the answer to the question. What happens when the perimeter, what happens to the perimeter when the dimensions multiply by 5? The perimeter multiplies by 5. I know we already knew this answer, but what we've now done is algebraically proven it for every triangle, not just a single example. The second question is about area. I'm going to rewrite my numbers in here, but they're going to be the exact same. So we had A, B, C, and then we had 5A, 5B, 5C. And now let's do the same thing. So let's start with our original area is 1/2 base times height. So in this case, that would be 1/2 A times B, because that's where the right angle is. And our new area is going to be 1/2 times 5A times 5B. Now again, our goal right now is to manipulate this side of the equation until it looks, or part of it looks like this. So what I see is this. I see a 1/2 and an A and a B, and there's just a couple of extra 5s. So as we manipulate, what we're going to do is basically just move those 5s out to the front. I'm going to write this as 5 times 5 times 1/2 times A times B. All I've done is taken each of these components and rearrange them until they're in a form that I want to see. I'm going to simplify this one more time to write 25 times 1/2 AB. You notice 25 is just the 5 times 5, 1/2 AB stayed the same. Here is the key. 1/2 AB is the original area. So I can rewrite this 1/2 AB as A sub 0, original area. Running out of space here, but I'm almost done. So this is equal to 25 times A sub 0. I'm going to bring the A down again just to make this clear. What this mathematical statement says is the area of the triangle is equal to 25 times the original area. That's the answer. You probably already knew this because you've done examples like it before, but this work, again, we've now proven it for every triangle. So our answer is the area multiplies by 25. We did not do a volume example in this video, but the volume examples are all very similar to this area example. Compared to the perimeter example, volume is usually closer to this. So our objective today was that we demonstrated the effects of changing dimensions on perimeter, area, and volume. In fact, we proved these effects, and we were using algebraic manipulation.